Hi guys, so this last video is talking about acid and base neutralization. Neutralization is a type of chemical reaction that you guys will have to be able to identify. So as a general formula, we always start with an acid and a base. Those are your reactants. And when you let them react, you get salt. So that's just like any ionic compound that doesn't end in OH, and you get water as one of your products. Okay, so to show you a more specific example of exactly what happens, let's take HCl as my acid and NaOH as my base. And then let's say you guys would have to figure out what the products of this neutralization reaction would be. We're always going to take the H from the acid and the OH from the base, and when we put them together, we get water. Two H's and one O. Now, whatever you have left over, guys, is going to make up your salt. For an ionic compound, we always write the metal first. So of my two things that are left, I have Na and Cl. I want you to remember that you can't just take these two ions and write them next to each other and assume that that's going to be their formula. You want to look up their oxidation states. So sodium is in group 1, chlorine is in group 17. You want to crisscross those oxidation states, and you do end up getting NaCl as the formula of your salt. Okay, but it doesn't always work out to be a 1-to-1 ratio, so you want to check that first. What type of reaction is this? This is a more specific kind of double replacement reaction. We start with two compounds and we end with two new compounds. But if you notice that your starting things are acids and bases and your ending things are salt and water, then you know more specifically it's neutralization. Now, we talked about this in class a little bit today when I did the milk of magnesia demo. As far as creating neutral products, you have to be very specific about the amount of acid and base you add together to perfectly neutralize one another. And you also want to think about the strength of the acid and the base that you're mixing together. In order to neutralize a strong acid, you have to mix it together with a strong base. And that's going to give you a neutral product. Same thing if both are weak. If you have a weak acid, you can mix it with a weak base, and that will give you something neutral. If you take a strong acid and a weak base, that weak base is not going to have enough power to neutralize that strong acid. So it will bring the pH up a little bit, but it will create a weak acid, not something that's neutral. Same thing if you have a weak acid and a strong base. That strong base is going to overpower your weak acid, and you'll end up getting a weak base as your product instead of something neutral. So you do want to pay a little bit of an attention to what kinds of substances you're mixing together and the amounts. Now, a titration is a technique that we can use in the lab, and we're actually going to do this in class. You guys are going to do a titration, and what you do is you take an acid and a base, one of those things you don't know the concentration of, and you're going to mix the two together until you get a neutral solution, and you're going to take those numbers that you collect and plug them into a formula to find the concentration or the molarity. So let's take a look at molarity. Molarity is moles divided by liters, right? So if I wanted to find the number of moles, I would do the molarity times the liters, which is a volume, right? And that's going to give me moles of H. If it's a base and I want to know what the moles of OH are, I would just do the molarity of the base times the volume of the base. So to take those two formulas and put them together, if I have a neutral solution, my moles of hydrogen ions and my moles of hydroxide ions have to be equal to each other. So I can say, oh, okay, well, the molarity of the acid times the volume of the acid is the moles of H plus, and that has to equal the molarity of the base times the volume of the base. And that's going to give me my moles of OH that have to be equal to each other. Now, when acids and bases dissociate and they break up into ions, if your acid has more than one H in it, the molarity of hydrogen ions is going to be more than the given molarity. Same thing with your bases. If they have more than one OH ion in them, when they dissociate and break up into ions, your molarity is going to double or triple depending on how many OH ions you get per mole of the whole molecule itself. So I just want to add to this formula that you should always multiply your acid side by the number of H's and your base side by the number of OHs. Okay, so this is your formula. When you do a titration in the lab, all the data you collect will get plugged into this formula, and then you just solve for an answer. So let's take a look at a word problem, and then we'll take a look at what this lab setup would look like. So it says, in a titration, I have 20 milliliters of KOH. KOH is a base, so 20 milliliters is the volume of the base. And it's exactly neutralized by 10 milliliters of 4 molar HCl. HCl is my acid, so 4 molar is the molarity of the acid, and 10 milliliters is the volume of the acid. And I'm finding the molarity of the base. That's what I don't know. So I'm going to take my formula, MAVA. The molarity of the acid is 4. The volume of the acid is 10. The molarity of the base, I don't know. The volume of the base is 20. And then I want to say, all right, how many H's are in my acid? 1. I want to multiply that side by 1. And how many OHs are in my base? 1. And I want to multiply the base side by 1. Okay? So 40 equals 20x, x equals 2. And I was solving for molarity, so my units are going to be capital M. Okay, so that's what I did here. I looked at how much acid and base I mixed together to make a neutral solution, and I solved for the molarity or the concentration of the base because that was unknown. Okay, I want you guys to try this one on your own, and I'll just give you a hint. Pay attention to the fact that this acid has 2 H's in it. Okay, so when you do your setup later, you make sure you pay attention to that. All right, and finally, guys, this is a picture of a titration setup. So in a nutshell, right, we have, we usually start in class when we do this. We're going to start with our acid in this container plus phenolphthalein, which is an indicator. If phenolphthalein is in an acid, it should be colorless. Okay, then this is called a burette, right? And we fill this burette up with base. Okay. And just to keep in mind, guys, we know the molarity of this acid and we know the volume of the acid that we put in this flask. So that's all stuff that we know. In this column, there's base, and we're going to know the volume of the base because we're going to count how much base, when we open up this nozzle here, the base is going to pour into the acid, and we're going to count how much base we added to the acid. Now, how are we going to know when it's neutral? Phenolphthalein is pink when you have a base and colorless when you have an acid. So when this solution here turns light pink, we're going to know that we're just about neutral, right? So if I have MA and VA and I have VB, the only thing that I need to solve for is MB, the molarity of the base, and that's what we're going to be able to find when we do this lab tomorrow. Something else that's worth looking at right now is how a burette is numbered. It's actually numbered upside down, opposite of a graduated cylinder. See how I have 39 up here and 40 down here? When I open up this nozzle and my liquid starts pouring into this flask, the level of this meniscus is going to go down, right? And what we want to do is we want to look at where we started and where we ended to figure out how much base we added to that flask. And you want to understand that because it's numbered upside down, you want to read it upside down. So this would be 39.1. This would be 39.2, 39.3, 39.4, 39.5, all the way up to 39.6, 39.7, 39.8, 39.9, 40 milliliters. Okay, so you're going to get a look at this tomorrow and see how we read those things. All right, that is it for acids and bases. See you guys tomorrow.